Selected problems from 5.2. We want to graph this. We want to identify first all the parameters. So the parameter A is an understood 1 on the outside of the base. The parameter B is -1, which is a coefficient of x. The parameter C is a positive 1, which is here. And the parameter D is -2 sitting here. So we're going to remove all the parameters and get our graph down to its basic, which will be 3/5 to the x power. Next, we'll put our parameters back on, starting with C. So this will be 3/5 raised to the 1 plus x power. Next, our B parameter, so we'll have 3/5 raised to the 1 minus x power. And then A is understood, so we'll go to our D parameter. So this will be 3/5 to the 1 minus x power, all minus 2. Okay. Graphing the basic functions. We have a base that is between 0 and 1. Therefore, we know that this is graphed by having a horizontal asymptote of y equals 0, a y-intercept of 0, 1, and the nature of the graph will be rapid to slow decay. Next, we have a C parameter of 1, positive 1. This will move everything to the right one time. So, moving y equals 0 to the right one time still gives us the asymptote y equals 0. Moving our point 0, 1 back one time gives us the point -1, 1. The orientation of the graph is still the same. It's rapid to slow decay. Next, we have a negative C parameter. The negative C parameter is going to give us a reflection about the x-axis, what we call a symmetric about the x-axis. So, when we flip our horizontal asymptote y equals 0 about the x-axis, it remains y equals 0. When we flip the point -1, 1 across the x-axis, it goes to this side and becomes the point 1, 1. The orientation also changes. From a rapid to slow decay, we get a slow to rapid increase or growth. And finally, the -2 here moves everything down twice. So my horizontal asymptote goes from y equals 0 to y equals -2. My point here, which is 1, 1, moves down twice to the point 1, -1, and the orientation of the graph is still the same. Okay, so these are the three pieces that need to be shown for graphing F. Now the domain and range. To find the domain, we look to see how far along the x-axis the graph goes and how far along left and right does this graph go along the x-axis. And that is from -infinity to positive infinity, all real numbers. For the range, we ask ourselves how low and how high does this graph go along the y-axis? Well, there's an asymptote down here, so it won't go any lower than -2. Asymptote, we'll use parentheses. And it'll go as high as positive infinity. So this is our domain and range. Number 4. We want to solve this equation for x. First, I want to convert my decimals into fractions. So this will be 1, and this is only a tenths place, or one single place. So this will be 1 over 10 to the 2x minus 1. This is 2 places, which is a 100th place, so this will be 1 over 100 raised to the 2 minus x. Okay. Now I'm going to take the reciprocal of the bases. This will give me whole numbers. And so this will become 10 to the 2x minus 1, and this becomes, when I take the reciprocal of the base, it will change the signs of the exponents. So this becomes 10, a negative 2x, and a positive 1. When I take the reciprocal of this base, the exponent now becomes a negative 2 and a positive x. Okay, now, next I want to look for a common base. I have a 10 and a 100. The common base is 10. This will remain 10 to the negative 2x plus 1, but this will become 10 to the second power, raised to the negative 2x plus x. Now I have powers raised to powers, so these will multiply. So what I'll get is 10 to the negative 4 plus 2x power. And now we have common bases. Now that we have common bases, we can equate exponents, and negative 2x plus 1 will be set equal to negative 4 plus 2x. Then solving for x by adding 2x to both sides, I get 1 equals negative 4 equals 4x. Then I add 4 to both sides, and I get 5 equals 4x. Dividing both sides by 4, I get 5 over 4 equals x. Number 8. I have a base of 2 and a base of 1.25. I want to convert this into a fraction. So this will be 2 to the x equals 125, and 3 decimal places represents 1,000. Now, I want to simplify that fraction, so I got to find a common factor. So I say 25 is a common factor. 25 goes in the numerator 5 times. 25 goes into 100 4 times with a 0 left over. And then I can still simplify this to 5 goes into 5 1 time, 5 goes into 40 8 times. Okay, so I have a base of 2 and a base of 1/8. I want to take the reciprocal of my 1/8, which will give me 8. This will change the power to a negative. From here, I have a base of 2, a base of 8. The common base will be 2. This remains 2 to the x. 8 becomes 2 to the third, still raised to the negative first power. Powers raised to powers will multiply, so we'll get a negative 3. And now that we have common bases, we can equate the exponents. And this implies x equals negative 3 for a solution. Number 10. We want to see if we can get common bases here. So let's start off with the base. That's 1.5. Okay, so I'm going to convert these into fractions. So this will be 15, and it's one place over, so that's over 10 to the x minus 2. This will be 225, and this is 2 places, so this will be over 100 to the x plus 2 power. Okay, there's a common factor of 5 here, so this will reduce to 3/2 x minus 2. Okay, I have a common factor of, I believe, 25. So that's 9, that one, and 4 for the denominator. And x plus 2. Okay, I can see here that I have a common base. If we're using the 3 and the 9, the common base will be 3. And for the 4 and the 2 and the 4, the common base will be a 2. Okay, so this will remain 3/2 to the x minus 2 power. This will become 3/2 to the second power, all still raised to the x plus 2 power. Okay, now I have powers raised to powers, so those will multiply. So 3 over 2 to the x minus 2 equals 3 over 2 to the 2x plus 4. Okay. Now that we have common bases, we can equate the exponents. So we have x minus 2 equal to 2x plus 4. And now solving for x, I'll subtract x from both sides, and I'll get negative 2 equals x plus 4. And then subtract 4 from both sides. We end up with a negative 6 equals x.